to start again, 2 pi over 3 cosecant squared 1/2 t dt. You'll remember we had something similar the first one. Okay, perfect. So what could be the problem here? What would you like to get rid of, if possible?
One half t, right?
Exactly. And right away, dy equals 1/2 dt. So I have the dt, I don't have the 1/2. No problem. A poor number I can always make up. So now 1/2 and dt will be in dy. This and this are already here. What else I have? Can anyone change this for us? Because I can no longer copy anything in t. When I move from t to y, I move completely from t to y.
Cosecant squared y.
That's it. Now careful with the limits of integration. When t is pi over 3, pi over 3 times 1 over 2 is pi over 6. When t is 2 pi over 3, we get pi over 3. I'm going to copy it again because it's squeezed in there and I don't like it. So from pi over 6 to pi over 3, and we have cosecant squared y dy. Now I have 2 from pi over 6 to pi over 3, which function prime is cosecant squared.
Negative third tangent.
Excellent. Good. So then we have -2 outside. Leave the constants outside. So I have cotangent pi over 3 minus cotangent pi over 6. And if you remember, we talked about this. Who cares about these numbers? Nobody. It's so easy to make them up quickly. So cotangent is cosine over sine. That's all you need to remember. This one is the square root of 3 over 2, and this one is 1/2. So when you flip, you will get 1 over the square root of 3, which changes into the square root of 3 over 3. So this is the square root of 3 over 3. The other one is the reversed. So it has to be the square root of 3. Because it will be the square root of 3 over 1/2, over the square root of 3 over 2 over 1/2. So that's how we get that. So that's our answer. Okay, so -2, the square root of 3 over 3 minus the square root of 3. If you want to incorporate the negative somehow, you can to the square root of 3 and minus 2/3 the square root of 3, or you can factor out the square root of 3. You can do whatever. This is good. This is good. It doesn't matter. Good. Let's go back to more examples. I have not looked at the WebAssign, but if you have not tackled that, it would be, I don't know, not easy to finish it up by Monday. So you can ask other questions. Okay, anything else you would like to work on? Any indefinite integrals from WebAssign or from the book? Anything?
Can we do number 31?
31, very good. 31. 31, I see it. Very good. So 31 is the integral from e to r 2 plus 3e to r, and everything to 3/2 dr. Fine. Awesome. Good. What bothers you? So to speak, in this problem.
2 plus 3 e to the r.
That's exactly what bothers me too. Perfect. But now I have to make sure that dy is easily makeable. So can anyone give us dy? And remember, that is not the derivative.
Three e to the r dr.
And now all I have to look is to see if I have e to the r. I do. If I have dr, of course I do. I'm missing the 3. So now I have the 3 as well. 1/3. Can anyone change this integral and forget about r? You cannot write anything with r in here. R is gone. Anyone?
Y with 3/2 dr.
You mean dy? Yes. Very powerful. Good. Awesome. That's it. So this is 1/3. Y to 3/2 plus 1, which is 5/2. And remember, we have to divide by exactly the same number. Since it's indefinite, I have to write plus a constant c, and it's not done. I will flip and get 2 over 15. And now I have to go back to the substitution and write 2 plus 3 e to r to 5/2. N plus c. And this is the final. If you have any doubts, no problem. We'll differentiate this, and you will see we will get the answer e to the r times 2 plus 3 e to the r to 3/2, guaranteed. When we differentiate this, we will have to get e to the r parentheses 2 plus 3 e to the r to 3/2. We don't need anyone to tell us whether this is correct or not. Okay? Anything else? Do you need any help with WebAssign again? I always get scared when there are not enough questions on WebAssign because I'm asking myself, okay, are my students on the right track?
Can you swap back over to the paper view?
Yes? Other questions? Can I switch back to the book? Yes?
Sure.
No, did you finish?
Yeah, no, it's okay.
Okay. We worked on 23 last time. Is there anything else you would like to work on? 25 is a good one. Is the integral from natural log x squared divided by x dx. Okay, what bothers you now? I know this is not the scientific way of finding the substitution, but I'm hoping that this will trigger your understanding. What do you think this is what is the problem here? What substitution do you think we should look at?
ln x.
Yes, because it's inside something squared, right? So this is the inner function, this is the outer. So this is what I want. As long as du is in the problem. Yes. dx over x. So can anyone translate this for us?
U squared du.
That's it. Which is u to the third over 3 plus a constant c, but I have to go back. It's mandatory to go back to the original variable in all indefinite integrals. Perfect. We didn't even need any adjustment. Here I needed an adjustment of 3. Multiply and divide by 3. But here I didn't even need anything. It was all straightforward after the substitution. Good. Do we want to look at more indefinite, more definite? Both? This problem, for example, 27, should not be in this chapter. But that's my opinion. Because it's places in chapter 7. It's a big discussion on this in chapter 7. So secant squared tangent cubed d theta. Did they write du again? No. Okay. Good. So in this particular case, that's what I'm saying, it's not obvious. The substitution is not obvious. Well, we can analyze two situations. Basically, will I denote u the secant theta or u tangent theta? If I use this notation or substitution du, which is secant tangent, d theta, is possible. But let's see. So if secant theta is a 1 secant, it's okay, I have a u. Then the secant with tangent, the second secant with a tangent, will be okay with d theta. And then I'm left over with tangent squared. And if I think about tangent squared, if you remember, there is one very important identity. 1 plus tangent squared theta equals secant squared theta. So it appears that it's okay, but more work. Let's try the other one. du equals secant squared theta d theta. And now this is very clear what I have to write. How would you translate now the integral from theta directly to u?
U cubed du.
That's it. So then it's u to the 4th over 4 plus a constant c, and I have to go back to the substitution. Our substitution was tangent. So I have tangent to the 4th divided by 4 plus a constant c. Very easy to check. You differentiate this to get secant squared tangent cubed. Guaranteed. 4 comes in front, you cancel the 4. You have tangent to the 3rd times the inner function prime, which is secant squared. Again, I don't think that this, it's okay, but I think it belongs in chapter 7. But that's fine. Okay, do we want to see anything? So you're not asking anything from WebAssign, which means that all integrals from WebAssign are clear and done. Is that clear? Is that what I should assume? Or you didn't even get to those? Is anyone with me, please?
I didn't get to 5.5 yet.
Okay. So in that case, I think we should work on choose something else. Thank you for letting me know. So no one will get penalized for that, but just let's choose other problems then and work on them.
You have a discussion prompt opening in 1 minute.
Yes. Okay. So let's stop and